Now in this lecture I'll find out the area of the green shape using two different methods. In the drawing we have a quarter circle, AOB is a quarter circle. Inside this quarter circle we have quadrilateral ACOD. So we have to find out the area of the green quadrilateral ACOD. In addition, you know that side AC of the quadrilateral equals to 24 units in its length, side CD equals to 7 units in its length, and this angle ACD equals to 90 degrees. Again, our mission is to find out the area of the green quadrilateral ACOD. So first of all, because of the fact that AOB is a quarter circle, it means that this angle must be equal to 90 degrees. So angle AOB equals to 90 degrees. And the point O is the center of the circle that will be created by completing the quarter circle to a circle. So from the center of the circle that we can create here, that is to say from point O, we will draw perpendicular on chord AC. So this angle equals to 90 degrees. This angle will be also equal to 90 degrees according to our construction. We define the touching point of the perpendicular from point O and AC as P. So here we have rule number 11. According to rule number 11, the perpendicular to a chord drawn from the center of a circle bisects the chord. Point O is the center of the circle. From point O, we go perpendicular OM on chord AB. That is to say, this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. Okay, so if OM is perpendicular to AB, then OM must also bisect AB. That is to say, AM equals to MB. Okay, so we can implement rule number 11 in our drawing. Why? Because in our drawing, from the center of the circle that we can create here, that is to say from point O, we do perpendicular on AC. According to construction, this angle equals to 90 degrees and this angle equals to 90 degrees. Therefore, according to rule number 11, the perpendicular OP also bisects chord AC. That is to say, AP equals to PC. In total, AC equals to 24. So if OP bisects chord AC, it means that the first half AP must be equal to 24 over 2, that is 12. And the second half PC must also equal to 12 units in its length. So actually, this is the implementation of rule number 11 in our drawing. Okay, from point D, we go perpendicular on PO. So actually, this angle equals to 90 degrees. And this angle will be also equal to 90 degrees according to our construction. We define the touching point of the perpendicular from point D in PO as Q. So we created there quadrilateral PCDQ. Inside quadrilateral PCDQ, or QPCD, we have 1, 2, 3 right angles. The sum of 3 right angles is 19 times 3 is 470 degrees, plus the missing 4th angle. In total, the sum of those 4 angles must be equal to 360 degrees according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, the missing angle here must be equal to 90 degrees. In order to complete the sum of the angles in this quadrilateral to 360 degrees, the missing angle here must be equal to 90 degrees. So inside quadrilateral QPCD we have 4 right angles. Therefore, we relate to quadrilateral QPCD is a rectangle, and we also know that the opposite sides of a rectangle are equal to each other. That is to say, side CD must be equal to side PQ and rectangle PCDQ. But CD equals to 7, therefore QP must be also equal to 7 units in its length. Likewise, in the same rectangle, side PC must be equal to side QD, but PC is 12, therefore QD must be also equal to 12. In the next step, we define the length of this, the line segment QO as X. QO equals to X according to our definition. We will focus on the right triangle QOD, this right small triangle, and we define angle ODQ as alpha. So in this small right triangle OQD, this angle equals to alpha. This angle equals to 90 degrees. Therefore, the missing angle here must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees. That is the sum of the angles in any triangle. So this angle equals to 90 degrees minus alpha. We define 90 degrees minus alpha as beta, and therefore this angle will be equal to beta. The big angle AOB minus beta must be equal to the missing angle AOP. I write it down. The missing angle AOP must be equal to 90 degrees minus this angle beta. So 90 degrees minus beta. Beta is 90 degrees minus alpha, so we substitute beta here by 90 degrees minus alpha. We'll open the brackets here. 90 degrees minus 90 degrees is 0, and minus times minus is plus. So in total, this expression equals to alpha. So we found out that the missing angle AOP equals to alpha. So here, this angle AOP equals to alpha. So in the right triangle AOP, this right triangle AOP, this angle equals to alpha. This angle equals to 90 degrees. Therefore, the missing angle must be equal to 90 degrees minus alpha. But 90 degrees minus alpha equals to beta according to our definition. Therefore, this angle must be equal to beta. In the next step, we focus on the right triangle QOD. So I copy the right triangle QOD. And we find out the value of tangent alpha in this right triangle. Side QO equals to X according to our definition, and QD equals to 12 units, and again ODQ equals to alpha, So actually, this is the right angle QOD that they copied from the original drawing. QD equals to 12 units, QO equals to X according to the definition. In this angle QOD equals to alpha. In this right angle QOD, we will get that tangents alpha equals to QD over QO. Tangents alpha equals to QD over QO. QD is 12 and QO is X. Again, Q angle QDO equals to alpha. So this is angle alpha. Again, angle QDO equals to alpha. This is angle QDO. This is equals to alpha. So in this right triangle QDO, tangent alpha equals to QO. Again, tangent alpha equals to QO over QD. But again, tangent alpha in this right triangle QOD equals to QO over QD. QO equals to 12 and QD equals to X. So in conclusion, found out that in this right triangle QOD, tangent alpha equals to X over 12. QO is X and QD is 12. So in conclusion, found out that tangent alpha equals to X over 12. In the next step, I'll copy the right triangle APO in a new page and we'll find out the value of tangent alpha in this right triangle APO. Side AP equals to 12 units in itself, and side PO it is equals to PQ plus QO. That is to say, PO equals to PQ, that is 7, plus QO, that is X. So in total, PO equals to X plus 7. So this is the right triangle APO that I copied from the original drawing. In this right triangle APO, tangents alpha will be equal to AP over PO. AP is 12 and PO is X plus 7. So in total we found out that according to equation number 2, tangents alpha equals to 12 over X plus 7. So we have two different expressions for tangents alpha. Therefore we get equation number 3. According to equation number 3, tangent alpha according to equation number 1 must be equal to tangent alpha according to equation number 2. So tangent alpha according to equation number 1 is equal to x over 12, and it must be equal to tangent alpha according to equation number 2. That is actually equals to 12 over x plus 7. The next step we first multiply this equation, and we get that x times x plus 7 equals to 12 times 12, that is 144. We'll open the brackets on this side of the equation and we get that x times x is x squared plus 7x, that is equals to 144. We subtract 144 from this equation and finally we get that x squared plus 7x minus 144 equals to 0. So this is a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. In this general formula, a, b, and c are the coefficients of the quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following formula: x equals to minus b plus minus square root of b squared minus 4 times ac over 2a. Okay, so here also a, b, and c are the coefficients of the quadratic equation. In our specific quadratic equation, the coefficient a equals to 1, the coefficient b equals to 7, and the coefficient c equals to minus 144. Now we put the data inside the equation for x, and we find out the value of the values of x. I will remind you that x, according to our definition, x is the length of this line segment QO. So we get here that x equals to minus b, b is 7, so minus b is minus 7, plus minus square root of b squared, b is 7, so b squared is 7 squared, that is 49, minus 4 times a is 1, times c is minus 144. All divided by 2a is 1, so 2a is 2 times 1, that is 2. So x equals to minus 7 plus minus square root of minus 100 times minus 4 is 576, plus 49 is 625. So inside the root we left only with 625 over 2. So we found out actually that x equals to minus 7 plus minus the square of 625 is 25 over 2. So here we have two solutions that are possible for x. The first solution for x is that x equals to minus 7 minus 25 over 2. Minus 7 minus 25 is minus 32, and minus 32 over 2 is minus 16. So in conclusion, found out that x equals to minus 16, but because of the fact that ax is the length, and the length must be a positive number, we cancel the solution. X cannot be a negative number, so we left only with the second solution that is possible for x. X equals to minus 7 plus 25 over 2. 25 minus 7 is 18, and 18 over 2 is 9. So in conclusion, we found out that x equals to 9 units in its length. This line segment QO equals to x, and x equals to 9. So we have to find out the area of this green shape. In order to find out the area of the green shape, we will divide the green shape into 3 parts. The first part will be the area of the right green triangle APO. We define the area of the right triangle APO as A1. The second part will be the area of the right triangle OQD. We define the area of this right triangle as A2. And finally, the third part will be the area of rectangle PCDQ. We define the area of the rectangle as A3. And it is obvious that the area of the green shape in total will be equal to A1 plus A2 plus A3. So I write it down. The area of the green shape in total will be equal to A1 plus A2 plus A3. We calculate each area separately, and then we add the three areas together. It must be equal to the area of this green shape. So A1 is the area of the right triangle APO, so I copy the right triangle APO in a new page, and we find out the area of this right triangle. Side AB equals to 12 units in its length. PO equals to 7 plus x. X is 9, so in total PO equals to 7 plus 9, that is 16. So actually A1 is the area of this right triangle APO. The area of this right triangle is equals to AP times PO over 2. AP is 12 times PO is 16 divided by 2. 16 over 2 is 8, and 8 times 12 is 96. So in total we found out that A1 equals to 96 square units. In the next step we find out the value of A2, that is actually the area of the right triangle OQD. So we copy the right triangle OQD here, and we find out the area of this right triangle. OQ equals to x, and x equals to 9. QD equals to 12. So actually, this is the right triangle OQD. This is covered from the original drawing. OQ equals to 9 and QD equals to 12. The area of this right triangle will be equal to QD times QO over 2. QD is 9 times QO is 12 over 2. 12 over 2 is 6. So in total, this expression equals to 6 times 9, that is 54. So A2 equals to 54 square units. And finally, we find out the area of A3. A3 equals to the area of rectangle PCQD. The area of any rectangle equals to the length of the rectangle times the width. The length is BC and the width is PQ. PC is 12, PQ is 7, and 12 times 7 is 84. So I found out finally that A3 equals to 84 units, 84 square units in its length. Repeat again that the area of the ring shape in total is equals to A1 plus A2 plus A3. We have already found out that A1 equals to 96 square units, plus A2 equals to 54 square units, plus A3 that is equals to 84 square units. 96 plus 54 it is 150, and 150 plus 84 it is 234. So I found out that the area of the ring shape in total is equals to 234 square units. That is the answer to our question. In the next step, I will present to you how to find out the area of this green shape according to the second method. In the second method, we join points A and D together by a straight line. By joining points A and D, we created the right triangle ACD. So we copy the right triangle ACD and we find out the length of the hypotenuse AD by implementing the Pythagoras theorem on this right triangle ACD. You know that side AC equals to 24 and side CD equals to 7. The only missing side is the side of the hypotenuse AD. So actually, this is the right triangle ACD that is copied from the original drawing. By PT is the relation from Pythagoras theorem. According to the Pythagoras theorem, we get that AD squared equals to AC squared plus CD squared. So AD squared, that is the square of the hypotenuse, equals to AC squared. AC is 24, therefore AC squared is 24 squared, that is 576 plus CD squared. CD is 7, so therefore CD squared is 7 squared, that is 49. In conclusion, we found out that AD squared equals to 576 plus 49, it is 625. We take out of this equation and find out that AD equals to the square root of 625, that is actually 25. So we found out actually that the length of the hypotenuse AD of this triangle ACD is equals to 25 units. We know that AOB is a quarter circle, therefore this angle AOB must be equal to 90 degrees. And also point O is the center of the circle that we will create by completing a quarter circle to a circle. Now we complete this quarter circle to a circle. We completed the quarter circle to a circle. Point O is the center of the circle, point A is the point of the circle itself, therefore OA is the radius of this circle. We define the radius of this circle as R, therefore OA equals to R. We will extend the radius AO by a straight line until it touches the circle. We will define the touching point of the extended radius AO and the circle is point M. AM is a chord that passes from point O, that is the center of the circle. Any chord that passes through the center of the circle must be the diameter of the circle. Therefore, AM is the diameter of the circle. Point O is the center of the circle, point M is the point of the circle itself, therefore OM is the radius of the circle, that is equal to R. So in total, AM equals to R plus R, that is 2R. AM is the diameter, that is equals to 2R. In the next step, we will extend side CD until it touches the circle. But the question is, where the extended side CD will touch the circle. We will assume that side CD, the extended side CD, will not touch the circle at point M, but in any other point. For example, we assume that the extended side CD will touch the circle at this point, point N. So we will have, in this case, we will have peripheral angle ACN that is equal to 90 degrees according to what is given as the question, but still the peripheral angle ACN rests on chord AN that is not the diameter of the circle, and this contradicts rule number 5. According to rule number 5, any peripheral angle that is equal to 90 degrees must rest on the diameter of the circle. Here we have peripheral angle MAN that is equal to 90 degrees. And this peripheral angle MAN rests on MN that is the diameter of the circle. But here we found out that this peripheral angle ACN that is also equal to 90 degrees doesn't rest on AM, that is the diameter of the circle. It contradicts rule number 5, because according to rule number 5, this peripheral angle ACN that is equal to 90 degrees must rest on AM, that is the diameter of the circle, but it is actually rest on AN, that is not the diameter of the circle. So due to this contradiction, we conclude that the extended side CD must touch the circle at point M exactly and not in any other point. So we extend, here the extended side CD we touch the circle exactly at point M. Actually, CDM is one straight line because we extended the straight line CD by straight line. Therefore, CDM is one straight line. We focus on this side of the diameter AM. AM is the diameter, it is absolutely a straight line, so we focus on this side of AM at point O. The sum of the angles on this side of AM at point O must be equal to 180 degrees according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have? At this side of AM at point O, we have this angle that is 90 degrees plus the missing angle. In total, they must be equal to 180 degrees according to the rule that I mentioned. Therefore, the missing side here must be equal to 90 degrees. In order to complete the sum of the angles on this side of AM at point O to 180 degrees, the missing angle here must be equal to 90 degrees. In the next step, we prove that the right grand triangle AOD is congruent to the right grand triangle DOM. So I write it down. The right grand triangle AOD congruent to the right triangle MOD. So why those two right triangles congruent to each other? First of all, AO in the grand triangle must be equal to side OM in the right triangle. AO equals to OM. Repeat again. AO equals to OM. They are both the radii of the circle, therefore they are equal to each other. In addition, those two angles are both equal to 90 degrees, therefore they are equal to each other. So angle AOD in the grand triangle equals to angle MOD in the right triangle repeat again. Angle AOD in the grand triangle equals to angle MOD in the right triangle. They are both equal to 90 degrees, therefore they are equal to each other. And finally, side OD is the common side that belongs to both triangles, so we can write down that side OD equals to itself. Repeat again. Side OD equals to itself as a common side that belongs to both triangles. So actually proved that triangle AOD, the green triangle, congruent, this is the sign of congruent, to the right triangle MOD, according to side angle side rule. That is to say, those two sides and the angle between them in the green triangle congruent to those two sides and the angle between them in the right triangle. Therefore, those two right triangles congruent to each other according to side angle side rule. And from the fact that those two right triangles congruent to each other, we conclude that side AD in the green triangle equals to side DM in the right triangle. Repeat again. AD equals to DM, according to the rule that corresponding sides in congruent triangles are equal to each other. Those two triangles congruent to each other, therefore the two corresponding sides, that is to say AD and DM, must be also equal to each other. But AD equals to 25, so we can write here that AD equals to 25. And from this equation, 25 equals to AD equals to DM, we derive that DM is also equals to 25. DM equals to 25, this like DM equals to 25 units in its length. And therefore, in total, CM must be equal to CD plus DM. That is to say, CM equals to CD, that is 7, plus DM, that is 25. So, CM equals to 7 plus 25, that is 32. In the next step, I will copy the right triangle ACM. And in your page, we implement in this right triangle ACM the Pythagoras theorem. AC equals to 24 units, and AM is the diameter of the circle, that is equal to 2R. So finally, this is the right triangle ACM that I copied from the original domain. AC equals to 24, CM equals to 32, and the hypotenuse AM equals to 2R. According to the Pythagoras theorem, here by PT is the version for Pythagoras theorem. According to the Pythagoras theorem, in this right triangle ACM, you will get that AM square equals to AC square plus CM square. AM is 2R, therefore AM squared is 4R squared, and it is equals to AC squared. AC is 24, therefore AC squared is 24 squared, that is 576, plus CM squared. CM is 32, therefore CM squared is 32 squared, that is 1024. So in conclusion, found out that 4R squared equals to 576 plus 1024, that is actually 1600. Here we divide this equation by 4, and finally we get that R squared equals to 1600 over 4 is 400. We take a root out of this equation and we get that R equals to the square root of 400, that is 20. So the radius of this circle R equals to 20 units. In the next step, I will copy the right triangle AOD. In your page, we will find out the missing side OD of this right triangle by implementing the Pythagoras theorem on it. The hypotenuse AD equals to 25, and AO is the radius, that is 20. So hopefully, this is the right triangle AOD that I copied from the original drawing. By PT is the version for Pythagoras theorem. According to the Pythagoras theorem, in this right triangle AOD, AD squared must be equal to AO squared plus OD squared. Okay, so AD is 25, therefore AD squared is 25 squared, that is 625. and it is equals to AO square. AO is 20, therefore AO square is 20 squared, that is 400, plus OD square. OD is the missing side, so we leave it as it is. We subtract 400 from this equation and we get that 625 minus 400 is 225. That is equals to OD square. We take out of this equation and finally we get that OD equals to the square root of 225, that is 15. So here actually side OD of the right rectangle AOD equals to 15 units in its length. What is the area of the green shape? The area of the green shape, actually we divide the area of this green shape into two parts. The first part will be the area of the right green triangle AOD that we will define as A1. And the second part will be the area of the green right triangle ACD that we will define as A2. It is very clear that in total the area of the green triangle will be equal to the sum of the area of the triangle AOD plus the area of triangle ADC. That is to say, it will be equal to A1 plus A2. So I write it down. The area of the green shape in total it will be equal to A1 plus A2. A1 is the area of the green triangle AOD, so I'll copy the green triangle AOD here and we'll find out the area of this green triangle. So A1 is the area of this green triangle AOD. The area of this green triangle will be equal to AO times OD over 2. That is to say, it will be equal to AO, that is 20, times OD, that is 15, over 2. 20 times 15 is 300, and 300 over 2 is 150. In conclusion, we found out that A1 equals to 150 square units. The only thing that is left to do is to find out the area of A2, that is actually the area of the right green triangle ACD. So we copy the right green triangle ACD in new page and we find out the area of this green triangle. Repeat again, the area of A2, it is actually the area of the green triangle ACD. I copied the triangle ACD here. The area of this right triangle ACD will be equal to AC times DC over 2. AC is 24, DC is 7 over 2. 24 4/2 is 12, and 12 times 7 is 84. And we already found out that A2 equals to 84 square units, and we already found out that A1 equals to 150 square units. The area of the green shape in total is equals to A1 plus A2. This is to say it is equals to A1, that is 150, plus A2, that is 84. 150 plus 84 is equals to 234 square units. So the area of the green shape in total it is equals to 234 square units. Okay, so in the next step I'll summarize the lecture. We start with the first method. So in the drawing we have a quarter circle, AOB is a quarter circle. Inside this quarter circle we have quadrilateral ACOD. Our mission is to find out the area of this green quadrilateral AOCD. In addition, you know that side AC of the quadrilateral is equal to 24 units in length, side CD equals to 7 units in length, and this angle ACD equals to 90 degrees. Again, our mission is to find out the area of the green quadrilateral ACOD. Because of the fact that AOB is a quarter circle, it means that this angle AOB equals to 90 degrees, and point O is the center of the circle that we can create by completing this quarter circle to a circle. So from the center of the circle, that is to say from point O, we draw perpendicular on chord AC. So this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point O and AC as P. And here we have rule number 11. According to rule number 11, the perpendicular to a chord drawn from the center of the circle bisects the chord. Point O is the center of the circle. From point O, we go perpendicular OM on chord AB. That is to say, this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. So whenever you have a chord from the center, whenever you have perpendicular from the center of the circle, whenever from the center of the circle you have a perpendicular to any chord, then that perpendicular you will also bisect the chord. In this case, because OM is perpendicular to AB, therefore OM will also bisect chord AB. That is to say, AM equals to MB. Okay, so we can implement rule number 11 in our drawing. Why? Because in our drawing, from the center of the circle, that is to say from point O, we draw perpendicular OP on chord AC. Therefore, according to rule number 11, the perpendicular OP also bisects chord AC. That is to say, according to rule number 11, AP equals to PC. But because of the fact that in total AC equals to 24, it means that each half will be equal to 24 over 2, that is 12. So AP is 12 and PC must be also equal to 12 according to rule number 11. Then from point D we do perpendicular on PO. So this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. We find the touching point of the perpendicular from point D and PO is Q. In this way we created quadrilateral PCQD. Inside this quadrilateral PCQD we have one, two, three right angles. This angle equals to 90 degrees according to what is given as the equation. Angle is equals to 90 degrees. So we have three right angles. The sum of three right angles is 90 times 3 is 270 degrees. Plus the size of this fourth angle. In total, it must be equal to 360 degrees. According to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, the missing angle here must be equal to 90 degrees. In order to complete the sum of the angles in this quadrilateral to 360 degrees, the missing angle here must be equal to 90 degrees. So inside quadrilateral PC, the Q we have four right angles, therefore we will relate to this quadrilateral PCDQ as a rectangle, and we know that the opposite sides of a rectangle are equal to each other. That is to say, PQ equals to CD. But CD is 7, therefore PQ must be also equal to 7. Likewise, in the same rectangle PCDQ, PC must be equal to QD, but PC is 12, therefore QD must be also equal to 12 units in its length. Okay, then we defined line segment QO as X, and then in the right triangle OQD, we define this angle as alpha. This angle equals to 90 degrees, therefore the missing angle must be equal to 90 degrees minus alpha. Why? Because alpha plus 90 degrees minus alpha is 90 degrees. And 90 degrees plus 90 degrees, it is equal to 180 degrees. That is the sum of the angles in any triangle. Okay, so I copy the right triangle OQD in a new page here. This is the right triangle OQD. Side QD equals to 12 units in its length. This angle equals to alpha according to our definition. QO equals to X according to our definition. In this right triangle QOD, tangent alpha equals to QO over QD. So tangent alpha equals to QO, that is X, over QD, that is 12. So in conclusion found out that tangent alpha equals to X over 12 according to this equation, equation number 1. Then we have here this angle equals to 90 degrees minus alpha, but we defined 90 degrees minus alpha is beta, therefore this angle equals to beta. Angle AOB equals to 90 degrees because AOB is a quarter circle. So 90 degrees minus beta must be equal to the missing angle AOP. AOP equals to 90 degrees minus beta. Beta is 90 degrees minus alpha, so we can substitute beta here by 90 degrees minus alpha. We did it, and we got that 90 degrees minus beta, it is 90 degrees minus 90 degrees minus alpha. We open the brackets here, and found out that 90 degrees minus 90 degrees is 0, and minus times minus is plus, so in total this expression equals to alpha. So the missing angle here, angle AOP equals to alpha. In the right triangle AOP, this angle equals to alpha. This angle equals to 90 degrees, therefore the missing angle here must be equal to 90 degrees minus alpha. But 90 degrees minus alpha is beta, so this angle actually equals to beta. Then I copy the right triangle APO. In a new page, and you found out the value of tangent alpha in this right triangle APO. This is the right triangle APO that I copied from the original drawing. AP equals to 12 units. PO is PQ plus QO, that is to say PO is PQ, that is 7, plus PO, that is X, so in total PO equals to X plus 7. PO equals to X plus 7, and this is angle alpha. So in this right triangle APO, we'll get the tangent alpha equals to AP over PO. AP is 12 and PO is X plus 7, so in total, according to this equation, equation number 2, we found out actually that tangent alpha equals to 12 over X plus 7. So we have two different expressions for tangent alpha. Therefore, we create equation number 3 that states that tangent alpha according to equation number 1 must be equal to tangent alpha according to equation number 2. Tangent alpha according to equation number 1 must be equal to tangent alpha according to equation number 2. Tangent alpha according to equation number 1 is X over 12. And it must be equal to tangent alpha according to equation number 2, that is 12 over X plus 7. So So we cross multiply this equation and found out that x times x plus 7 equals to 12 times 12, that is 144. We open the brackets on this side of the equation and finally found out that x times x is x squared plus 7x equals to 144. We subtracted 144 from this equation and found out that x squared plus 7x plus 144 equals to 0. This is a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. Here, a, b, and c in this general formula are the coefficients of the quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to this special formula. X equals to minus b plus minus 4 of b squared minus 4 times ac over 2a. In our specific quadratic equation, x squared plus 7x minus 144 equals to 0. The coefficient a equals to 1, the coefficient b equals to 7, and the coefficient c equals to minus 144. So we put the data inside this equation in order to find out the value of x. X equals to minus b, b is 7, so minus b is minus 7, plus minus root of b squared, b is 7, so b squared is 7 squared, that is 49, minus 4 times a is 1, times c, that is minus 144. Minus 4 times minus 144 is 576, plus 49 in total is equal to 625. So inside the root we left only with 625. And we found out that x equals to x equals to minus 7 plus minus the square root of 625 is 25 over 2. We have here two solutions that are possible for x. The first solution for x is that x equals to minus 7 plus minus 7 minus 25 over 2. Minus 7 minus 25 is minus 32, and minus 32 over 2 is minus 16. So finally we found out actually that the first solution for x is that x equals to minus 16. But because of the fact that x is the length, x is the length, and the length must be a positive number, we cancel this solution for x that is a negative number, and we left only with the second solution that is possible for x. X equals to minus 7 plus 25 over 2. 25 minus 7 is 18, and 18 over 2 is 9. So in conclusion, found out that x equals to 9. This 9 segment QO that is equal to x is equal to 9 units. So what is the area of the green shape? We divided the area of this green shape into three parts. The first part is the area of the right triangle APO that we defined as A1. The second part is the area of the right triangle OQD that we defined as A2. And finally the third part of the green shape is the area of rectangle PC DQ that we defined as A3. It is obvious from the drawing that the total area of the green shape equals to A1 plus A2 plus A3. So here the area of the green shape equals to A1 plus A2 plus A3. We calculated each area separately and then we added the three areas with each other, and this is actually the area of the green shape. A1 is the area of the right triangle APO, AP equals to 12, PO equals to x plus 7, and x is 9, so in total PO equals to 9 plus 7, that is 16. The area of this right triangle APO is AP times PO over 2. AP is 12, PO is 16 over 2. 16 over 2 is 8, and 8 times 12 is 96. So in conclusion, found out that A1, that is the area of the right triangle APO, equals to 96 per unit. Then we found out the value of A2. A2 is the area of the right triangle OQD. OQ is x, that is to say it equals to 9. QD equals to 12 units. So the area of this right triangle QD equals to OQ times QD over 2. OQ is 9, QD is 12 over 2. 12 over 2 is 6, and 6 times 9 is 54. In conclusion, found out that the value of A2, that is the area of the right triangle OQD, equals to 54 square units. Then we found out the value of A3. A3 is the area of rectangle PC DQ. The area of any rectangle equals to the length times the width. The length is 12 and the width is 7, therefore in total the area of the rectangle must be equal to 12 times 7, that is 84. That is to say, we found out that the value of A3 is 84 square units. And in total the area of the green shape equals to A1 plus A2 plus A3. A1 is 96, A2 is 54, and A3 is 84. 96 plus 54 is 150, 150 plus 84 is 234. So conclusion found out that the area of the green shape in total it is equals to 234 square units. Then I presented to you how to find out the area of this green shape according to the second method. In the second method, we joined points A and D. In this case, we created the right grand triangle ACD. I copied the right grand triangle here. This is the right grand triangle ACD that I copied from the original drawing. Side AC equals to 24, side CD equals to 7 units, according to what is given as the equation. According to the Pythagoras theorem, in this right triangle ACD, AD square equals to AC square plus CD square. So AD square equals to AC square. AC is 24, therefore AC square is 24 squared, that is 576, plus CD square. CD is 7, therefore CD square is 7 squared, that is 49. So in total AD square equals to 576 plus 49, that is 625. We took out of this equation and finally found out that AD equals to the square root of 625, that is 25. So here the length of the hypotenuse AD equals to 25 units. Then we completed, first of all, because of the fact that AOB is a quarter circle, this angle AOB equals to 90 degrees, and point O is the center of the circle that we will create by completing this quarter circle to a circle. We actually completed this quarter circle to a circle. So point O is the center of the circle, point A is the point of the circle itself, therefore OA is the radius of this circle that we define as R. Then we extended the radius AO until it touches the circle at point M. Point O is the center of the circle, point M is the point of the circle itself, therefore ON is also the radius of this circle that is equal to R. So we have chord AM that passes for point O, that is the center of the circle, and any chord that passes for the center of the circle must be the diameter of the circle. Therefore AM is the diameter of the circle. The length of AM is R plus R, that is 2R. Then we extended side CD by side line until it touches the circle. We assume that it will touch the circle at point N, and then we arrive to a contradiction to rule number 5, because according to rule number 5, any peripheral angle that is equal to 90 degrees must rest on the diameter of the circle. But here we have peripheral angle ACN that is equals to 90 degrees, and it doesn't rest on AM that is the diameter of the circle, but it rests on AN that is not the diameter of the circle. It is a contradiction to rule number 5. In order to avoid the contradiction, we will conclude that CD, the extended CD, must touch the circle at point M and not in any other point. In this way, we will not have any contradiction at all, because we will have peripheral angle ACM that is equal to 90 degrees, and indeed, this peripheral angle that is equal to 90 degrees, it rests on AM that is the diameter of the circle, exactly according to rule number 5. So, the extended side CD touches the circle at point M and only at point M. Then we focused on this side of the straight line AM at point O. The sum of the angles must be equal to 180 degrees, therefore the missing angle here must be equal to 90 degrees. Then we prove that the green right triangle AOD is congruent to the white right triangle MOD. Why those two triangles congruent to each other? First of all, AO equals to OM. Repeat again, AO equals to OM. They are both the radii of the circle, therefore they are equal to each other. In addition, those two angles are both equal to 90 degrees, therefore they are equal to each other. Angle AOD in the green triangle equals to angle MOD in the white triangle, they are both equal to 90 degrees, therefore they are equal to each other. And finally, side OD is the common side that belongs to both triangles, so side OD equals to itself. OD equals to OD, it's a common side that belongs to both triangles. So we actually proved that the green triangle congruent to the right triangle according to side angle side rule. Those two sides and the angle between them in the green triangle are correspondingly congruent to those two sides and the angle between them in the right triangle. Again, therefore those two right triangles congruent to each other according to side angle side rule. And from the fact that those two right triangles congruent to each other, we derive that the following. We derive that AD equals to DM. Okay, AD equals to DM. AD equals to DM according to the rule that corresponding sides and congruent triangles are equal to each other. Those two triangles congruent to each other, therefore the two corresponding sides AD and DM must be equal to each other. AD equals to DM, but AD equals to 25, so we can write here that AD equals to 25, and from this equation 25 equals to AD equals to DM, we will derive the DM also equals to 25. Here this line DM equals to 25. Therefore, in total, because of the fact that CDM is one straight line, CM in total will be equal to CD plus DM. That is to say, CM equals to CD, that is 7, plus DM, that is 25. That is to say, CM equals to 25 plus 7, that is 32. AC equals to 24, and AM is the diameter of the circle, that is equal to 2M. So I copied the right triangle ACM in a new page and we implemented this right triangle ACM, the Pythagoras theorem. This is the right triangle ACM that I copied from the original domain. AC equals to 24, CM equals to 32, and AM is the diameter of the circle that is equal to 2R. According to the Pythagoras theorem, in this right triangle AM square equals to AC square plus CM square. AM is 2R, therefore AM squared is 2R squared, that is 4R squared, and it is equal to AC squared. AC is 24, therefore AC squared is 24 squared, that is 576, plus CM squared. CM is 32, therefore CM squared is 32 squared, that is 1024. In conclusion, found out that 4R squared equals to 576 plus 1024 is 1600. So in conclusion, found out that 4R squared equals to 1600. We divided this equation by 4 and finally found out that R squared equals to 1600 over 4. 1600 over 4 is 400. We took out of this equation and finally found out that R squared equals to R equals to the square root of 400, that is 20. So the radius of this circle R equals to 20 units in its length. In the next step, I copied the right green triangle AOD in the new page and we found out the missing side OD by implementing the Pythagoras theorem on this right green triangle AOD. This is the green right triangle AOD that I copied from the original domain. AO equals to 20 units, it is the radius of the circle. AD, the hypotenuse, equals to 25. According to the Pythagoras theorem, in this right triangle AOD, AD squared equals to AO squared plus OD squared. So AD is 25, therefore AD squared is 25 squared, that is 625, and that is equals to AO squared. AO is 20, therefore AO squared is 20 squared, that is 400, plus OD squared. OD is the missing side, so we leave this it is. We subtracted 400 from this equation and finally found out that 625 minus 400 is 225. So 225 equals to OD squared. We took out of this equation and finally found out that OD equals to the square root of 225, that is 15. The missing side here, OD equals to 15 units in its length. What is the area of the green shape? The area of the green shape equals to the area of the right green triangle AOD, that is A1, plus the area of the green right triangle ACD that we defined as A2. In total, the area of the green shape equals to A1 plus A2. I repeat again, the area of the green shape equals to A1 plus A2. A1 is the area of the green right angle AOD. I copy the green right angle AOD here, and we found out the area of this right angle. The area of this right angle equals to OD times AO over 2. AO times OD over 2. AO is 20, OD is 15 over 2. 20 times 15 is 300, and 300 over 2, it is 150. So the area A1 equals to the area of the right triangle ADO, that is 150 square units. Then we found out the area of A2, that is the area of the right green triangle ACD. I copied the right green triangle ACD here, and we found out the area of this green right triangle. Side AC equals to 24 units, side CD equals to 7 units, according to what is given us the question. So the area of this green triangle ADC equals to AC times DC over 2. AC is 24, CD is 7 over 2. 24 over 2 is 12. So in total, this expression equals to 12 times 7, that is 84. Finally, we found out that A2, that is the area of this right triangle ACD, equals to 84 square units. While we have already found out that A1 equals to 150 square units. Again, the area of the green shape equals to A1 plus A2. A1 is 150 and A2 is 24. 150 plus 24, it is equals to 234. In conclusion, we found out that the area of this green shape equals to 234 square units. Okay, thank you very much.